Okay, so if you've already completed Tuesday's practice, then you'll know that today we're going to be working on practicing using these exponents to write our exponents in expanded form using multiplication, or taking repeated multiplication and writing them in exponent form. We're also going to be evaluating some of our expressions and finding the value of them, and we're going to be using the area formula and the volume formula to practice writing our exponents as well. All right. For our first set of practice problems, it says rewrite each of the following products using exponents. Do not evaluate. The first one is done as an example. So when I look here, I see 5 times 5 times 5, and they wrote it as 5 to the third power, or 5 cubed. So now I see 12 times 12. I know my base is 12. I see 12 getting multiplied 2 times, so my exponent is 2 to the second power, or squared. Now I have 7 times 7 times 7 times 7. So I need to think, what is my base? What's the number that's being multiplied repeatedly? That's right, your 7. Then I'm going to see how many times is my 7 being multiplied. 1, 2, 3, 4. So my exponent is to the power of 4, or to the fourth power. For this last one over here, see if you can figure out which number is going to be your base and which number is going to be your exponent. All right, so when I look at D, you would see that your 9 is being multiplied repeatedly, and I would see how many times. 1, 2, 3, 4, 5, 6. 9 to the sixth power. All right. Now we're going to make our way down to number 2. Write each of the following in its expanded product form. So expanded, it's going to be larger. Product, I know that I'm going to be multiplying. Do not evaluate. The first one is done as an example. So in my first example, I see 8 to the fourth power. I see my base 8 being multiplied 1, 2, 3, 4 times. All right, so now I'll try B. I'm going to think which number is going to be my base. My base is going to be 15. How many times is 15 being multiplied? 3 times. So 1, 2, 3. And I don't have to evaluate, so I don't need to find the value. Now I have 11 squared, or 11 to the second power. Take a minute and write this one on your own. All right. Check with me, and you should have something that looks like this. 11 times 11. Now we have our last one, 6 to the fifth power. Take a moment and try this one on your own. Think to yourself, what's my base, and how many times is that base being repeated? That's right. So my base is 6, and it's being repeated 5 times. So 1, 2, 3, 4, 5. For question number 3, our directions say, write each of these exponents as a product and then find the value of the product. So I'm going to write a product, right? And then I'm going to find the value. I'm going to see how much it is. So I have my base as 2, and my 2 is being repeated 4 times, 2 to the fourth power. So 1, 2, 3, 4. So now I have 2 times 2 times 2 times 2. Something that helps me is I break it up a little bit. I have 2 times 2 is 4. Then I have this multiplication symbol. Then I have 2 times 2 is 4. And now I have 4 times 4 equals 16. That's right. Now we'll slide over to B. I have 12 to the second power. So how many times is my 12 repeating? 2 times. 12 times 12. So now I'm going to multiply 12 times 12. This should be something that you've practiced with your multiplication tables. All right. Now I have 7 to the third power. So my base is being repeated 3 times. 7 times 7 times 7. Now before you say 21, remember, it's not 3 times 7, it's 7 times 7 times 7. So I know 7 times 7 is 49. And now I have to see what's 49 times 7. That's not something that I can do in my head, so I'm just going to do my algorithm on the side. I'm not going to say this part out loud because we've practiced with our algorithm a lot, and I'd like you to practice on your own. So just check along with me and see if you got the same thing. All right. Now I have 20 to the second power. So I have my base that's being repeated 2 times. I can look at my basic facts and I know that 20 times 2 is going to be 40. And then I'll add on my extra placeholder 0 and I'll get 400. Take a moment and see if you can set up these last two by yourself. If you're having trouble multiplying, that's okay. See if you can at least write it in expanded form. Go ahead and give that a try now. If you've gotten to this part, wonderful. Now we'll go over solving it. I have 9 times 9, which is 81, times 9. Don't worry about ever having to do your algorithm. That's okay. You have tools in your toolbox to help you solve questions like this. Great. 25 times, now I have 25 times 25. 5 times 5, 5 times 2, plus 2, placeholder 0, 10, 4 plus 1, add up my partial products, which gives me 625. All right. As we flip over to our back page, we have question 4, 5, 6, and 7. So question 4, which of the following has the value of 15 cubed? 15 cubed. Well, when I think of cubed, I think of a cube. And it makes me think of volume, where I do length times width times height. So I know I'd be multiplying 15, and it'd be repeating 3 times, 15 to the third power. So I need 15 times 15 times 15. I'm going to start with my first 15 times 15. 5 times 5. 5 times 1 plus 2. Add my placeholder. 1 times 5. 1 times 1. I'm going to add up my partial products. 5 plus 0. 7 plus 5. 1 plus 1. But remember, I'm not done. I still have to multiply my product by this 15. So now I have 225 times 15. 5 times 5. 5 times 2, 10, 11, 12. 5 times 2. I'm going to cross off my placeholders. I'm going to add my placeholder 0. And I'll do the second row a little more quiet. It's for people who want to try it on their own. All right, here we go. We found that choice. Now 5, using your math. A square has side lengths that each measure 28 feet. 28, 28. Write an expression using an exponent that represents the area A of the square. Well, I know area is length times width. And I know that I'm multiplying 28 times 28. So I'm going to have 28 2 times. So that means I'll have 28 to the second power. Question B. Evaluate the expression from A to find the square's area. Use the correct units. So now I'm going to solve 28 times 28. 8 times 8. 8 times 2 plus 6. Placeholder 0. 4, 8, 7, 784 feet squared. A cube has sides that measures 12 inches each. Write an expression using an exponent that represents the volume V of the cube. Well, I know volume equals length times width times height. I'm going to be multiplying 3 things, and I'm going to be multiplying 12 repeatedly for 3 times. So I'm going to have 12 to the third power. 12 is going to repeat 3 times. 12 times 12 times 12. So now, all done. So now I need to evaluate the expression to find the cube's volume. So now I need to find out what 12 times 12 times 12 is. Well, I know 12 times 12 is 144. Now I'm going to take this last times 12. We're getting a lot of good multiplication practice today. This one I'm going to do quietly, and you can try this one on your own. So after I've multiplied my 144 times 12, I have 1,728 inches cubed. Our last question. How many cubes that measure 2 inches by 2 inches by 2 inches would fit inside a cube that measures 10 inches by 10 inches by 10 inches? All right. Well, if I have a cube, you don't have to draw a cube. That's 2 by 2 by 2. I want to know how many of those will fit inside a cube that's 10 by 10 by 10. Okay, so first I'm going to find the volume of a cube that's this large and the volume of a cube that's this large. 2 times 2 times 2, 10 times 10 times 10. I know 2 times 2 is 4. 4 times 2 is 8 inches cubed. I know 10 times 10 times 10. I can take my 1 and add my placeholders. 1, 2, 3. 1, 2, 3 inches cubed. So now I want to know if the volume of this cube is 8 and the volume of this cube is 1,000, how many 8 inches cubed can fit inside of 1,000 inches cubed? Well, I can take my 1,000 inches cubed and divide it into groups of 8. So I'm going to see how many groups of 8 inches cubed can fit inside of 1,000 inches cubed. 8 can fit into 10 one time. 8 times 1 is 8. 10 minus 8 gives me 2. I was getting a little ahead of myself. I'll bring down my 0. 8 can fit into 20. 8, 16, 2 times. I'll find the difference. I'll bring down my last 0. 8 can fit into 40 5 times. So 125 cubes.